class 8 physics. We have completed the previous chapter, that is light, and we will be studying a new chapter, and the name of the chapter is heat. Okay, so we'll just be doing some introduction part today, not much. So this is a 7th class chapter, I guess, and or 6th class chapter. Okay, anyways, so we will be doing heat today. So as we continue, so what is heat? Okay, what is heat? Heat is a form of energy which gives us the sensation of hotness or coldness, isn't it? So it gives us a sensation whether how the transfer of heat or the how hot a body can be. It is the form of energy which gives us the sensation of warmth. Okay, that is your heat. Now you know heat always transfers from one body to another body. So what is heat transfer? First we'll understand that. Okay, what is heat transfer? So heat transfer is the movement of heat energy from one substance to another. So what is heat transfer? It is the movement of heat, that is transfer of heat from one body to another. Okay, so this is only the introduction part. Now see here more in detail. Heat always transfers from a warmer place to a colder place. There are so many examples in our day-to-day life, and you've studied this in class 7 as well, isn't it? That the heat always transfers from a body at a higher temperature to a body at a lower temperature. Okay, example. Say you keep a water which is cold. Okay, you just fill a bowl of water with the cold water, and then you heat some object. You can heat any metal. Okay, it can be a ball or something. When that metal is hot, just dip it in the cold water. So when you leave it in the cold water for some time, just leave it in that cold water for some time. Now after you come back after like 10 or 15 minutes, and when you touch the water, what do you feel? The water becomes warm, and the hot object that you have dipped in that water would be cold comparatively. Okay, it would not be so cold, but it will be cooler. So what is happening over here? Here the heat from the hot object has been transferred to the cold water. That means there has been transfer of heat from the hot object to the cold water. That's why both the bodies will have almost the same temperature. Okay, so heat always flows from a body at a higher temperature to a body at lower temperature till both the bodies attain the same temperature, and that is called thermal equilibrium, which you have studied in class 7. So we just revising it. Okay, that is called thermal equilibrium. When the heat transfers from a hotter body to a colder body till both the bodies attain the same temperature. Okay, the next one is objects in a cooler room will cool to a room temperature. So hot objects in a cooler room. So if you keep anything hot in a cooler room, room which is cold enough, if you keep it over there, the hot object for some time, what will happen? The hot object will become cold, which means the hot object has transferred its heat to the room, and the room becomes not so cold, but it becomes cool. Okay. Another one is cold objects in a warmer room will heat up to room temperature. So if you have a very warm room, okay, say you have turned on your heater and the room, the windows, everything is closed. So which means the room is very warm. And now you put something cold over there. You just keep something which is cold inside the room for some time, and come back after some. When you come back and check, what will you find? That the object has become warmer. Okay, not hot, but it becomes warmer than its initial temperature. So what does it prove? What does it state? That the heat transfers from a hotter body to a colder body till both the bodies attain the same temperature, and that is called thermal equilibrium. Now heat transfer, moving in more detail, heat can be transferred in 3 ways, isn't it? We don't have this in your class 8 book, so we're just revising what you have learned in class 7. Okay, so heat can be transferred in 3 ways. that is conduction, convection and radiation. Conduction by a substance which does not move. For example, solids, isn't it? When the particles are not free to move, they simply vibrate in their own place, and this is how they transfer the heat. Convection, when the particles are free to move. Okay, convection is possible by the particles which are free to move. Like liquids and gaseous particles, they are very much free to move compared to solids. The third one is radiation, that is used by the help of infrared. We don't need any medium here. Okay, the heat just transfers without any medium. So radiation is exchanged between all substances, irrespective of any matter. Okay. Now, this is what you have in your book, effects of heat. So there are various effects of heat. Okay, and some of the effects that we have over here is cause or change in temperature. That means if a body gets heated, what happens? Its temperature changes. So its temperature increases. If a body loses heat, its temperature decreases. So that's why we write cause or change in temperature. Next one is cause or change of state. That means when a body gets heated, say for example, an ice, when it gets heated, it melts into water, which means there is a change of state. The ice, which was in solid state, changed to liquid, changed to water, which is in liquid state. So there has been change of state from solid to liquid by the gain of heat. And vice versa, if water loses heat, if the water loses heat, it will change to ice, isn't it? When water loses heat, it converts into ice. So what is happening over here? The liquid changes its state to solid. So there will always be a change of state if there is heat. Okay, this is one of the effects of heat, change of state. Change of chemical reaction, in some chemical reaction heat is required. So when during a chemical reaction, if heat is supplied, the reaction takes faster, isn't it? And it's mandatory to provide heat for some chemical reactions. Okay, and then another one is cause or change in density. So this one we will discuss more in detail. Okay, cause and change in density means when the particles get heated. Say you have this wood over here. Now it has its density. Now the particles which are over here, suppose if I heat it for a longer time, what will happen? The particles over here, they start, moving around, they start vibrating faster. So this solid, they change into, it might change into liquid, or not exactly here in this case. I mean, the particles will be, what happened is the particles will be moving apart. Okay, the particles will be moving apart than when it was in the beginning. So they will be moving far more apart from each other. So what is happening? The volume will increase and the density will be different from what was it in the beginning. So there will be change in density also. Okay. Next one is the cause of change in shape. So if metal sheet is heated, it might be melted, isn't it? So these are the different effects of heat. The first one that we are going to discuss about is change in density. How heat causes change in density. Now see here. As a substance gets hotter, its atoms vibrate more strongly and take up more space. Like I told you in the beginning. When the particles get heated, what happens? They start moving far apart from each other. They start moving faster. And when they start moving faster, the intermolecular space increases. Okay, the intermolecular space increases and the intermolecular force of attraction between the particles, they decrease. So what happens? The space, suppose initially the space was this much between the two particles. Now when they get heated, it might increase to this much. Okay, so what is happening? The intermolecular space increases, and when the space increases, they spread. Okay, the particles start spreading, and when the particles start spreading, what is happening? They occupy more volume. And how is density related to volume? Indirectly. That means more volume, density decreases. Okay, let's take an example here. Say there are 10 students in the classroom, and if I just ask them to sit in a corner together, they just cram together and they just occupy this much space. But if I ask them to spread themselves, okay, if I ask the 10 students not to cram themselves, not to be so cozy to each other, and spread. So if they just take their respective place, or if I ask them to keep some distance, certain distance or 1 feet distance amongst each other. So what will happen if they were taking this much space? When I ask them to separate, they will be taking this much space, isn't it? So what is happening initially? The density was more because they were together. Now when the particles are together, density will be more. Now when they spread, what is happening? Volume increases. That means the space they occupy increases. Thus density will be less. Because if volume is more, density is less. Okay, as per the definition of density, which says density is defined as mass per unit volume. That means more the volume, lesser the density, and lesser the volume, more the density. Okay, most substances get bigger as they get hotter because the particles, as I told you, occupy more space. Because their mass stays the same, they become less dense, which means the density decreases. Okay, just a second, something had just popped up. Okay, so we usually measure this by how much a substance expands in one dimension, length or weight or breadth or height. For each degree Celsius, it decreases in temperature. This is called coefficient of thermal expansion. And this one, the coefficient of thermal expansion, we'll be doing in detail later in the same chapter. Okay, so I'll not be explaining you this one. Just a rough idea that when a body gets heated, it might increase in length, breadth or height. Okay, so depending on that, we have a term for all those particular expansion. So we'll be discussing that more in detail in the same chapter, but not today. So as of now, just understand that heat also causes change in density. And generally, heat, when a body gets heated, what happens? The density would be decreased because the particle starts moving apart and the volume will be more. Okay, next one we have here is change in state. Okay, change in shape. Now, generally, you've seen those rods, they've been melted, isn't it? You've seen those the metals, they are turned into thin sheets by beating them regularly, right? So when you beat them regularly, what is happening? There's friction, and friction causes heat. So if there is heat, even they might be changing shape. Okay, so if an object contains two substances with difference, that is due to length, its shape can change when it is heated. The side with the larger alpha, that is linear expansion, expands more, causing it to bend. Examples include thermostats and katana. This one katana where you use. Okay, it can also cause nuts and bolts to loosen if they are not made up of the same material. The nuts and bolts here. Okay. So generally, the shape, if I don't know if you have heard about this bimetallic strip, where two metals are used to make that strip, one strip, but two metals are used. Okay, so when they are heated, different metals take different time to get heated. So we use that concept to change in shape. So heat also causes change in shape. Even you constantly heat an iron, if you constantly heat an iron and with a very high temperature, if you just apply a lot of heat to an iron, what happens? It melts, isn't it? If it's heated for a longer time with a lot, and not just a small amount of heat, but if you add enormous amount of heat to that metal, what will happen? It will melt. Okay, that is changing in shape and changing state also. Now change in state. We discussed this, that the solid, when gains heat, can change to liquid. When liquid gains heat, can change to gases. When gases loses heat, can change to liquid, and liquid, when loses loses heat can change to solids. Okay, and solids can also directly convert when they gain a lot of heat. They convert directly into gases, and gases, when they lose a lot of heat, a lot of amount of heat, they convert directly to solid. So this one you've been studying a lot, so you might be knowing it already. Enough heat can change a substance's state. That is, once a substance reaches its melting or boiling point, more heat is needed to make it change its state. This is called latent heat of fusion, that is for melting. And this one we'll be discussing when we'll be discussing changing state more in detail. Okay. So just know that even the heat causes change of state. And why does the change of state happen? It is because when the solids they gain heat, the particles they start moving faster and the space between them increases. And when the solid particle space increases, that means the molecules of solids are tightly packed. So if they have more space, that means the solid has changed to liquid state. Similarly, when liquid gains heat, the space between the two particles increases furthermore, and then they change to gases. Now, these are the effects of heat from the book, so I'm just referring it to here. Okay, changing temperature of the body. Why do we have this changing temperature of the body? When a body is heated, its temperature rises. When it is cooled, its temperature decreases. The change in temperature of the body depends on the following two factors. The first factor, quantity of heat imparted to or rejected from the body. It means how much heat has been supplied to the body or how much heat has been taken away from the body. So how much heat does the body gain? How much heat does the body lose? So when heat is imparted to the body, its temperature rises, while if a heat is rejected from the body, its temperature falls. So the same story, okay, it's always the same, the same basic concept is the same. When the body gets heated, the particles they start moving faster, the kinetic energy increases, the intermolecular force of attraction between the two particles decreases, hence increasing the space between them. And when the space increases, what happens? So on the other hand, so what happens? The molecules move faster, then the kinetic energy increases, so temperature also increases. So on the other hand, on cooling, what happens? The kinetic energy decreases. That means the molecules will start moving slower. Okay, they will not move faster, they will move slower, which means the kinetic energy will be less. And if the kinetic energy is less, temperature will also be less. Okay. Another one is material of the body. The first one was how much heat is supplied to the body or how much heat is taken away from the body. The second factor which affects the temperature because of heat is material of the body. Now it also depends upon the kind of material that we choose to supply heat. Okay, say you supply 10 calories of heat to ice and 10 calories of heat to a metal. Okay, so ice of course melts. You can expect the metal to melt completely, isn't it? So what does it mean? It means it depends upon the material of the substance. So ice is made up of water, so it's a different material, and metal, when we talk about metal, is a different material, isn't it? So some materials rise to high temperature while some to a low temperature, even when same quantity of heat is imparted to them. The different materials have different specific heat capacity. That is, different amount of heat required to raise the temperature of the mass by unit rise in temperature. So if you take an iron nail and if you take a wood, okay, if you take an iron nail and a wood and you heat it, so they will be responding to different, if you supply the same amount of heat to an iron nail and a wood, they'll be responding differently, the same amount of heat. Okay, the same way if you take an iron nail or if you take an iron metal or if you take steel, so they will also respond differently to the same amount of heat because the material is different. So this is what we meant, material of the body. Okay. Okay, the second one is change in state, and change in state we'll be discussing more in detail in the next class. So I've just taken the third one, that is change in size of the body, which we have already discussed. So when a body is heated, it expands upon cooling, it contracts. This change in size of the body due to heating is called thermal expansion. Generally, all solids, liquids and gases expand on heating or contract on cooling. The reason is that on heating a substance, the average intermolecular separation between the molecules of the substance increases, while on cooling it decreases. So the same concept. Why? Why is there change in shape or size? Because the particles, they start, what happens when they gain heat? The particle starts moving apart, that means occupying more volume. Okay, which means the particles expands. And if on losing heat, what happens? The particles come closer, which means their volume will be decreased. Thus, what is happening over here? They will contract. Okay, so I think we have this, the expansion and contraction, the application of expansion and contraction in this book. So we'll be discussing that more in detail. As of now, just understand, any substance which gets heated, they expand. Okay, you might not be noticing it, but even the solids, they expand. But the expansion in solids are very negligible. Okay, and compared to liquids and gases. But all the objects, what happens when they gain heat, they always expand, and when they lose heat, they always contract. So we'll continue till here. We'll stop till here for today. And in the next class, we'll further continue with the chapter. Okay? So thank you and have a good day.